Hi guys, welcome to this video lesson. In this video, you are going to learn the Fehling solution. Here I will discuss the preparation, reaction and mechanism as well as application and limitation of this reagent. Okay, now let's have a discussion. The Fehling solution or the Fehling reagent. At first, look at the historical background of this Fehling reagent. The solution was developed by Hermann von Fehling in 1849. He was a German chemist and better known for Fehling reagent. Besides, he wrote a few books on chemistry. Now, let's see the preparation of Fehling reagent. This reagent can be prepared by mixing equal volume of two solutions, that is Fehling A and Fehling B. Here, Fehling A is a deep blue aqueous solution of copper 2 sulfate and Fehling B is a colorless solution of aqueous potassium sodium tartrate along with strongly alkaline sodium hydroxide. Here, this is the Fehling A solution and this is the Fehling B solution. Now combining these two solutions, it gives rise the Fehling reagent. This Fehling reagent contains bis-tartrate-cuprate 2 complex and then it furnishes cupric ion which act as oxidizing agent. The Fehling reagent can be used in the Fehling oxidation reaction. Now let's move on the main reaction of this reagent. When an aldehyde is heated with Fehling solution, it oxidizes to carboxylic acid and red copper oxide precipitates out of the solution that indicates the positive result. Here, this is the main reaction. This aldehyde molecule together with the cupric ion give rise to the carboxylic acid and red PPT of copper oxide. Here, this is the reaction. When the color of this reaction is blue, it indicates the negative test, that is, aldehyde and alpha hydroxy ketones are absent. In this reaction, cupric ion is converted to cuprous ion, that is, copper 2 is reduced to copperon. And now, this is the most important part of this video, that is the mechanism of this reaction. This mechanism involves the following steps. Firstly, base treatment of this aldehyde molecule leads to the formation of carbon-carbon double bond, and now this compound complex with this cupric ion and forms this complex molecule. Now this complex molecule is converted to this intermediate molecule. In these steps, this intermediate molecule undergoes nucleophilic attack by hydroxide ion at carbonyl carbon and then is converted to this intermediate molecule. In these steps, the carbon-copper bond undergoes the homolytic fission and forms the radical carbon. Now, this radical electron is transferred to cupric ion and this cupric ion is converted to cuprous ion. Finally, hydrolysis of this intermediate molecule gives the carboxylic acid. Okay, now let's see the application of Fehling reagent. Here I have mentioned some of its application. This reagent is used to test the monosaccharide, that is to detect reducing sugar like glucose. Also it is used to identify aldehyde or ketone functional groups. Formic acid also gives a positive Fehling test. Though it has many applications, but there are some limitations of the Fehling reagent. The limitations are ketones unless they are alpha hydroxy ketones, and aromatic aldehyde do not give this Fehling test. Well, that's all from me. Thanks a lot for watching this video lesson. If you like this video, please press the bell icon and subscribe my channel. If you have any question, please write it in the comment box and I will try to get back to you. See you soon.